see how long it will be.
Huh?
Something.
What are we talking about? Anyways, whatever. Okay, so let me just put the answer down for the first one again. What did I say the first one was? 0.5 newtons. Sorry. 0.5 kilogram meters per second. Okay.
No,
What's wrong? Number 2.
the answer is 0.2.
First one.
Yeah.
The first one, the answer is 0.2. Yes?
That's the answer.
What's wrong?
I thought you were writing.
I showed you this one already. I'm just doing this one.
Question 1?
Yes.
And this question 2?
Now we're on 2. So the cat falls off the roof. That's the cat. 5 meters high. So when the cat lands, the landing lasts 250 milliseconds.
No.
And
Just 12 minutes MS, that's all.
Yes, you just...
You don't milli per second.
It's not the product.
No, it's not the projectile. Anyways, it doesn't matter. We'll just get over it, okay? So look, how fast is the cat going when it hits the ground? Well, let's calculate. V squared equals U squared plus 2A S. So that means V equals square root, well, I'll just put the answer in. 2 times 9.81 times 5, square root the answer.
Minus 9.81?
Yeah, but then I have to put minus 5 in, so they both cancel. 9.90 meters per second. So that's how fast the cat's going when it hits the ground. So look, here's the cat. And the cat is going 9.9 meters per second, and then the cat bends its legs. And how fast is the cat going now? 0 meters per second. So my question is, and I actually give you the time here is 250 milliseconds, or if you want, 0.250 seconds. So my question is, what's the impulse? Okay, so isn't it? No, what's the force? So force is change in momentum over time, and then the change in momentum is mv minus mu over time, which I know. So the cat, how big did I say the cat was? 5.5. 5.50 minus 5.5, 9.9 over 0.25. Is that okay? So that is 218 newtons up.
So it means minus or...
Well, I wrote in up to make it clear. The force is going up because the ground is slowing the cat down.
So it's
What is minus in this case because I was taking down as plus? Is that clear now, Amanda and Sophie, or not clear?
Why is 0.25?
Because the question said the bending of the knees lasts 250 milliseconds. That's what I was trying to draw here in my picture. Look, Sophie, there is the cat straight, and then the cat bends the knees when the cat lands. So the cat is coming down, and then the cat now is at rest. What's wrong, Amanda?
How do you calculate the time?
Which time?
250.
This
Yeah.
is given in the question. No, I promise it is. There it is there.
It's the velocity?
No, that's the time.
-1 above.
These are milliseconds.
Ah.
Yeah. I know I wrote it wrong.
Yeah.
I know I wrote it wrong. I'm sorry. I shouldn't have written -1 on the S.
Yeah.
I should have just written
MS.
MS. Yeah. Well, you know, that's life when it happens. Yeah, we're all human here. Yeah. So sorry, that should be, let me fix it for you. MS.
Ah.
Now are we happy? Yeah. By the way, you all know my email address, don't you? So you can email me in the evening if you have
In
questions.
the middle of night.
Well, I'll be asleep in the middle of the night, but not in the evening.
So when you sleep,
About 1 a.m. usually,
So what's the last time you should see me?
not 1 a.m. Alright, next example. Can I go on?
Yeah.
Yeah. I'm sorry about the MS. I know I've been silly with it. It should have been MS, not with the -1. Okay, number 3. You are walking with a speed of 1 meter per second. Sorry, so I know I was being stinky here. Oh, I didn't write the M there, good. And the wind is blowing this way with a speed of 20 meters per second. And in this question, the wind, the density of the wind is, yeah, well, I wanted you to use the one in the example I did.
Yeah.
But, well, wind is wind, it's not going to be different. But anyway, we'll do 1 gram per meter cubed.
Just give it a minute.
Well, it is now. It was in the previous question with the wind.
Like that.
In the class I did. Yeah. Okay, anyways. Can you see that this is the same problem?
But one thing,
Yes.
he's not at the door or something, right?
No?
Or on the window.
Well, 1 second, let me go through it first.
Okay.
So can you see that this is the same problem as this?
No.
So can you see that these two are the same
Yeah.
situation?
Yeah.
In this one he's walking to the wind at 1 meter per second, and in this one he's at rest, but the wind is blowing at 21 meters per second. Can you see how they're the same? Because it's like, you know, if the wind is blowing and you start to walk into the wind, does it feel like there's more or less wind?
Yes.
More. So what I'm saying here is, this problem is the same as this problem.
Yeah.
Now the reason I'm doing that is it makes it easier if my man is not moving. Right, now again, I think I wasn't clear here. I wanted you to do the same information as the example I did in class. So how big was my man? I said he was, how tall was he? No. How tall was he, my example I did? You are the ones with the notebooks. Can you tell me in the example I did how tall was the man?
I don't know.
Don't make me come down to you now. Take out your notebook and look at the example I did. Here he is right here. He was 1.6 tall and 0.4 wide.
I have one thing.
Yes.
He's not standing in the window. He's not standing in front of the door.
No, he's not.
So how can you say the air is on the cube form?
I'm approximating it because I do not have the formula for the volume or area of a man. Only of a rectangle. So I'm saying he's like a rectangle. Okay? So what was his height? 1.6. And his width? 0.6 I said, wasn't it? Why don't you look in your notes that you wrote? What did it say in the notes? This is 0.4? Thank you.
to change the economic numbers?
Change what?
Change the quotient?
No. I wrote 0.6, but it was 0.4. It's 0.4, isn't it? Yeah.
Where's the door?
Huh?
Where's the door?
There's the door. No. This is not a door. This is a man.
Is it that?
It's a man. But what?
It doesn't make any sense.
Look, if I draw a man, okay, here he is.
There's extra space in underarm, there's extra space between legs.
I know it's an approximation. I'm saying he's like a rectangle. Roughly. He's a rugby player, okay? He's like a rectangle. You got it? Now look, after 1 second, how far does the wind travel? 21 meters. So if you think about it, it's like there is a box that's 21 meters long of wind. So the volume here is 21 times 0.4 times 1.6, which is 13.44 meters cubed. Now here density is mass over volume. So that means the mass is density multiplied volume, which equals 0.001 multiplied 13.44. Now look, I'm saying 0.001 because it is 1 gram. I need to convert it into kilograms. So divide by 1,000. Right, so divide by 1,000. So the mass of the wind is 0.01344 kilograms. Now the impulse is the change in momentum, which is mv minus mu, which will be 0.01344, and how fast is the wind blowing? 21. So this is 0.28224 kilogram meters per second. So finally, the force equals the impulse divided by the time, which will be 0.28224 divided by 1. So the force is 0.28224 newtons. So that's how much force he feels.
Can you ask for that?
Yeah.
Hold on, sir. So at the first, like u equals 1, and then you make it the rest. How do I know that?
U equals 1? Oh, here?
Yes.
No, what I'm saying is this problem is the same as this problem.
How do I know they are the same?
What do you mean?
Like you now said they are the same.
Well, think about it like this.
Same cases.
The wind is coming to me at 5, and I'm going to the wind at 1. So this is like the wind is coming to me at 6, and I'm not moving. It's also like, think about it like this. This car is going 10 kilometers per hour, and it hits into the wall. Okay? That's the same as if this car was going 5, and this car was going 5. They hit. It's the same as if the car was going 10, and this was not moving. Yeah, so like 10 and 0 crash is the same as 5 and 5 crash.
Okay, now first of all,
Yeah.
we cannot deal with the first situation or first case.
We can't, it's more difficult because both things are moving. It's easier if one thing is not moving and the other thing is moving. It's less complicated.
So the example changes to this number.
Oh yeah, just change it like how I did, yeah. Okay? Difficult, I know. But I have seen this in the exam.
We have to make a cube.
In fact, when it was the exam, it was already a piece of wood. It was a shop sign hanging out of a shop.
Absolutely.
Shop sign.
Shop sign.
I did today morning.
And
Today this question.
Did you?
Yeah.
In the SAP? The
Yeah.
shop sign? Yeah. So like this is what was in the exam.
Yeah.
As a physics student, you have to be willing to make approximations. It goes with the job. And I think the rectangle is quite reasonable actually. It's not that bad.
It's extra, extra space.
It's not that bad because you can kind of ignore the head. It's mostly the body you care about. Alright. Now I am going to do number 4 because it's long. I'll do it in the tutorial.
No?
Number 4. I'll do it on Friday's tutorial.
Okay.
Because it's quite long. It'll take a few minutes to do. So I'll do that in the tutorial on Friday, okay? So we'll go to the next lesson now.